Hello everyone, in this video we are going to solve problem number 15 from chapter number 2, force vectors in the book of Engineering Mechanics, the static part by R.C. Hibbeler. In this problem we have been given with a plate which is subjected by the two forces which are acting through the members A and the B as shown in this figure. We are actually being asked to determine the magnitude of the resultant of these forces, and also we are being asked its direction measured clockwise from the positive x-axis. It's quite straightforward. I don't think it's much different from the one that we have solved before. Let's dive into it. So let's first consider the plate on which these forces are acting. The force which is acting through member A, which is FA, can be shown here. That has a magnitude of 400 pounds and makes an angle of 30 degree with the positive y-axis. The force which is through member B has a magnitude of 500 pounds and its direction is 60 degree with the positive x-axis. That makes an angle theta, and in this case we have been given that the theta is 60 degree actually. So first we are going to solve for the resultant of these forces, and once we determine its magnitude then we can determine its direction. So magnitude of the resultant force, you write the resultant force as Fr. So magnitude will be determined by cosine law. Keep on doing this since last few problems related to the force vectors where I mentioned that the cosine law is the one. If you know the angle between the two forces and the magnitude of these two forces, then we can simply determine the resultant. So the magnitude of FA, that will become square, magnitude of FB, that will also become square, plus 2FA FB cos the angle between them, and I represent them with alpha. So in this case we are not directly being given with the angle between FA and FB force, but we can determine, since this angle is 30, so this angle will be 60 since the total is 90. So the angle between FA and FB will become 120, because 60 and 60 will make 120. Now everything in this equation is known, we just put the values. So on putting the value, we are going to get, so 458 pounds, the value that you are going to get as the magnitude of the resultant force caused by these two forces are 400 and 500 pounds. The next thing, which is its direction. Now for direction of the resultant force, we will be using sine law. For that we have to put the tail of one force with the head of the other force. So we keep force A at the same point, and we will displace the force B by putting the tail of force B at the head of force A. By doing so, we are going to get this. I believe this makes sense to all of you. Like this was actually the FA force, and the FB force which was directed over here, I can place it over here as well according to parallelogram law. So the closing side means from the starting to the end of these two forces will actually be the resultant. So then this will be the resultant. We just have determined the magnitude of the resultant force, which was 458 pounds. So we are being asked to determine this angle, because you can see the direction measured clockwise from the positive x-axis. So this is the positive x-axis. Clockwise will be this angle, and let's say that the angle is beta. So we cannot directly determine this beta angle, but we can determine this angle, which is the interior angle of this triangle. So this angle is actually, the total angle will actually be 60 plus beta, because this angle is 30, so this will be 60. The remaining is a small angle, is actually the beta. Now what we are going to do, we are going to use the sine law, and for the sine law we need to know the one other interior angle. We cannot determine this interior angle because we don't know this beta angle, so we cannot determine this angle, but we can determine this angle, this interior angle. How can we do this? So if you see, this imaginary line and this y-axis are parallel lines, and this FA force is cutting through this. If this angle is 30, the opposite will also be 30. I mean from angle from here to the vertical. Similarly, this is a vertical line, this is a horizontal line. Total is 90, this is 60, so this will be 30. So as a whole, this is actually 60 degrees. Now, sine of any angle, but keep in mind we don't know this angle, so we are not going to use this angle, but we can use this angle, which is 60, divide by the magnitude of the force opposite to this angle, which is FR, that will be 458, and this interior angle is 60 plus beta, so sine 60 plus beta, this will be divided by the magnitude of the opposite force, which is 500. So now in this equation, which is obtained through using sine law, if you know the basics or if you know how it is being applied, you can see my previous videos where I have tried my level best to explain the sine law. And now if you look at this equation, you can see that there is only beta as the unknown variable. So when you're going to solve this equation, you're going to get beta as 10.9 degrees. This is what we wanted to know. This was the first part that was required to us. So this is how the calculations for the magnitude and direction will be done when we are being given with a body which is being subjected to the two forces. Their magnitudes and their directions are given to us. It's quite easy, but again, if you feel any difficulty, if you find something which is not understandable, then please let me know through the comment section so that I can get back to you. Before I end my video, let me tell you that I am also available for tutoring these kind of problems or any problem related to the engineering mechanics. I am available to help. Just reach me through the email which is given in this YouTube channel. Simply write into the comments. I'll get back to you. That's all from my side. Thank you for watching this video. I hope to see you in next coming videos. Till then, bye.